So this is the second session of statistics in R. So in the first session, we have seen some basics, for instance, basic concept of interpreter compiler, basic data types in R, and we have also written some basic scripts. So in this session, we are going to talk about a control flow like if else and looping construct in R. Then we will also see descriptive statistics. If we have a data, how we can generate descriptive statistics for that data. So let's begin. So this is the plan for this session. So first of all, we are going to do a small recap of the things we have learned in the previous session. Then we will see how to use loop and if else, and how to write a program with the help of these constructs. And then we will look on the vector. We will have a very quick review on the vector, how to create, access and delete. Then we will come to descriptive statistics, where we will talk about distribution of the data, mean, median, standard deviation, how to plot it, data. And these last two topic I have kept for next session. Okay, so for recap, I have decided to ask you guys to write a script. So this script will take three numbers from the user, x, u, sigma, and then what you have to do, you have to compute fx using this expression. So I decided to use this expression because it will allow you to see how you can use braces when you have to compute a long expression. And I will also show you how to write this script. So let's move to our R Studio. So I will create a new R script. So first we will take input from the user. So we will write a statement that will take input from the user. So let's say x. So in the last session, we have seen that when we use readline, it will store every data in the character, and in order to convert that character into the numeric format, we have used as.double. Okay, so similarly we will also ask for other two numbers. Okay, so now we have written three statements. So these three statements will take input from the user and store in x, u and sigma. Now what we have to do, we have to compute the expression. So just have a look on the expression again. So how we are going to do it, we are going to compute it in three steps. So in the first step, we will compute the first part, that is 1 upon sigma under root 2 pi. In the second step, we will compute this power part, minus 1 by 2 x minus u upon sigma whole square, and then we will put everything together. So in this script, we will also see how to compute square root and exponent. So let's go to our script. So I'm naming it first part. So the first part is 1 upon sigma root 2 pi. So I will write 1 divided by sigma multiply Now in order to compute the square root, I am going to use a function sqrt. You can open the help here. So as you can see, this is the function sqrt, and you specify the value in the function. So I have to compute the sqrt of 2 pi. So 2 multiply pi. So in our environment, the value of pi is available with the name pi. So this is the first part. So 1 divided by sigma multiply with square root of 2 pi. Now I'm computing power part. So the power part is minus 1 by 2. Then this minus 1 by 2 is multiplied with x minus mu upon sigma whole square. So let's write it. So minus 1 by 2, or I can simply write it 0.5 multiply with x minus u now x minus u divided by sigma whole square, or I can simply write it x minus u power 2 divided this one with sigma power 2. So I just instead of computing this whole square, I just converted it like x minus u square divided by sigma square. So this is our minus 1 by 2 0.5 minus 0.5 multiply with x minus mu square. So this is the power operator. You can use it if you want to compute some power, or you can simply use the multiplication. So x minus u multiply with x minus u, and then we are having sigma square. So we have computed power part as well. Now we are going to put everything together. So first part multiply with, now how to compute the E? So you can open the help exp. So as you can see, exp computes the exponential function. Now we simply need to specify the value here. So I will write exp, and here I will write the power part. So if you look at here, this is the power part of E, and in order to compute that in R, you have to use exp function, and then we have specified power part, and then I will print the result. Okay, I will save this one. Let's say fx.r. Now I'm going to execute it. So it is asking me the value of x. So let's say I'm giving 5, mean 5, and then sigma I'm, let's say, saying 2. So it gave me a value 0.1994711. Now this function is actually a probability density function for normal distribution. So we will talk about these distribution later. But if you want to see whether your program is working as expected or not, you can compare your result with the result with this function. So there is a function dnorm, and you specify all the value in the same order. So you first specify the value of x. So here we have specified 5, and then we have specified u5, and then we have specified sigma 2. So if the if the result of this function is same as yours, in that case your script is perfectly working. So if you can look at the result, this is equivalent to what we got from our script. So that means our script is perfectly computing that expression. So now we will move ahead. So this was the help we use in our script. So we use a sqrt function to compute square root, and we use exp function to compute exponential. Now we will see how to use if else. So I have taken a simple example here. So let's say let's look at this statement. There is a person, and the person is thinking of going to library, and then he's not sure whether the library is open or not. So there is a statement, if library is open, then I will go to the library. Now in this statement, if we look at here, so this is a kind of a condition. So the person is thinking like, if the library is open, if this condition is true, in that case he will take a action, and this part is considered as a action. So this is a simple statement. There is a condition, and when the condition is true, he will take the action. And if we look at this statement, if library is open, then I will go to the library, otherwise I will stay at home, study at home. So in this statement, we are having condition, we are having action, but then we are having another action. Now this another action will be performed by this person when this condition is not true. So this is just a simple example from our real life. Now we are going to see how this if else can be used. So this if else also use the same syntax. We specify some condition, and then we specify the task that has to be performed when the condition is true. And we will move to our R Studio. So here I will show you some of the example. So I'm going to write a very simple script, and before that I will ask you to open the help here. So this help will give you information on the how to use if else. So if you look at this one, so there is written like if, condition, and then expression. So let's use this statement. So let's say I want to write a condition. I want to see whether 10 is equal to 10. This is like just for illustration. So 10. Now if you want to compare two values in R, so the sign you will use is double equal. So we know this condition is true, but we want to use our if else, and that's why we are using very simple condition, and then we are printing some statement. Condition is true. So what your R interpreter did, it evaluated the condition. This condition is true, as we know, and then when the condition is true, this expression was executed. Now you can write another condition, 12 greater than 10. As we know, this condition is also true. So this expression will be executed, and this expression is simply printing a message 12 is larger number. Now let's write a false condition. So just reverse the sign. So if 12 is less than 10, and we know this is not true, so in that case this expression should not be executed. So let's press enter, and now we cannot see any message. So the thing is, this expression was not executed. And then we are going to use our if else. So I'm writing if, then a condition, then I'm writing expression 12 is smaller. So this expression is evaluated when this condition is true, but if this condition is not true, then this expression is evaluated. And as you can see, this condition was not true. In that case, the expression written after else is evaluated. So now we are going to use these syntaxes and we are going to write our R script. So this R script is asking us to check whether a number is positive or negative. So I'm simply taking a I'm simply storing a value in a variable. So let's say 10. And then I have written if a is greater than 0, print a is positive, else print a is negative. So we actually, instead of writing everything in a line, if you can see here, we have written everything in a single line. We can do the same thing here as well, but sometime instead of running a single statement, you want to execute a number of statements once the condition is true, and I'm going to show you here how we can do that. So you write if, then you write condition, and then you use curly braces. So this curly braces is actually allow you to write multiple statement. So everything written in these curly braces will be considered as a single block. So when the condition is true, everything written in these braces will be executed. And then we are having else. Now you need to pay your attention. If you are using curly braces, you have to write your else after the closing curly brace for if. Okay, so we have written if, then we have written a statement. So in this case, we have only a single statement, and we could have avoided this curly braces, but I'm using these curly braces to show you if you have multiple statements to be executed when a condition is true or false. In that case, you have to enclose all those statements in those curly braces. And when you use else, you have to write else on the same line where is your closing curly brace for if block. So now let's execute this script. So we know like a is having 10, and 10 is obviously greater than 0, and it should print a is positive, but let's see. So it has printed a is positive. Now what we will do, instead of fixing this value, we will take this value from the user. Okay, now I'm executing it. So now it's asking me a value, and I decided to give a negative value, -34. Okay, it gave me a is negative. Let me execute it again. I will click on the source, and this time I'm giving 0, and it said like a is negative. Why that happened? So if you look at here, 0 is not greater than 0. So in that case, condition was false, and we got the message a is negative, or our value is negative, but that's not the case. 0 is neutral. So what we can do here is, when this condition is false, for this case, like when we specify 0, so we will do here one thing. Instead of printing a is negative, we can again check here whether a number is equal to 0 or not. If a number is equal to 0, then we can print this is a neutral number. Otherwise, we can simply print negative. So we specified 0 greater than 0. This is not true. It will come in the else block. Now here we will write one more if. And now I'm running it again and I am giving 0. So this time it's that a is neutral. So these are just some of the example. You can give a try with other scripts, such as take a number from the user and check whether this number is odd or even. So now we are moving to our next concept, next construct. So loop. What do I mean by loop? So just think about a scenario. In a classroom, a teacher has asked a student to write something 100 times. Now, when we repeat a particular task, we have two things in our mind. First thing, target, like for how many number of times we have to do that task, or how many number of times this student has to write this some text. And then he also keeps a track on the current writing, like how many times he has written and what is the target. So similarly, in our script, we want to repeat some particular code multiple times, and in order to achieve that, we have a concept of loop. The another example we can have is, let's say we have a series of data, and here this data is very small, but still, like, we have a series of data and we want to process every item from this data in some particular manner. So how we can iterate over this data? So here we can again use loop. So we are going to have two different scenario and we are going to write a script. So we will have a script, we will write a script which will take a number from the user and then it will print its multiplication table. So for instance, it will take a number from the user and the number is 2. It will print 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And for loop, we are having for, while, repeat, and this break and next, they can be used in loop. So let me show you some simple example. So first we are going to see while condition expression. So let's say I want to print a number from 1 to 100. This is a very simple script and we can do this by simply using seq function. But I'm going to show you with the help of while loop. So first of all, I will take a variable and the variable has a value 1. Then I need to iterate a particular statement. So I want to print value from 1 to 100. So I want to print this variable value 100 times. Now in order to do that, I will follow this syntax, and this syntax says that write while, then write condition. So I am leaving this condition part for later, and then write expression. So here is our expression. So when you have single expression, this syntax is okay, but you have multiple expression, I will suggest you to write curly braces. Now what can be the condition? So we have to print I from 1 to 100. So 100 is the target. So we will check the value of I. It should be less than and equal to 100. So if we look at this script, a variable I is having 1. It will go here and the condition is true because 1 is less than 100. When the condition is true, it will execute print I and it will print 1. Then it will again check the condition. If the condition is true, execute the expression. So this process will run in an iteration. Now the question is, we just want to execute this loop from 1 to 100 and the value of I is always 1. Like in this case, the value of I is 1 and 1 is always smaller than 100. So this loop will keep on executing, so there is no ending. So if I will run this script, this program will never end. It will keep on iterating. Now what I want to do is, in order to in order to stop this loop, I will keep on changing the value of I. So first in the beginning the value of I is 1. Condition will be checked. 1 is smaller than 100. When the condition is true, it will execute everything what we have written inside the curly braces. So first it will print I, which is 1. Then it will increase the value of I by 1. So now I is having 2. It will again check the condition. 2 is smaller than 100. Condition is true. It will again execute everything written inside curly braces. It will print I, which is 2, and then it will increase the value. So now the value is 3. So in such a manner, this loop will keep on executing, and when the I value become 100, so just imagine that scenario when the value of I reaches 100. So 100 is less than and equal to 100. So 100 is actually equal to 100. So condition is true. It will print I. So I value is 100. It will print 100. And now I become 101. And this time condition will be false. And once the condition is false, the execution of this loop is over. So now I'm going to show you the execution. I will click on source. So if you can look at the result, it has printed from 1 to 100. Okay. Now the another example is how to iterate over a series of data. So let me create a vector. So let's say data, and my data is like salary, employee salary for 10 employee. Okay, so now I'm having a vector. This vector is actually representing salary data of employee in 1000 euros. So what I want to do, I want to iterate each of employee salary, and I want to print a salary only if the salary is less than, let's say, 15. So how can I do that? So first of all, I will show you how to use for in this case. So I will write for we let's say salary in data, and then you write print. So the meaning of this syntax, so you can read it like this way: for each salary in data. So in the beginning, this salary represent first element, it will print salary. Then it represents 15, then 14, 13, 21, 50, 34, and so on. So it will iterate over this vector. So if I will execute it, it will iterate over each item, and I am simply here printing that item, print salary. Now what I want to do, I want to print only when the salary is less than 15. So for salary in data, now I have multiple expression. So instead of writing a single expression, I have to write multiple. That's why I'm going to use curly braces. Sorry, I have to again. And here I will write a condition, if condition. So if salary is less than 15, I will print only in this case. So if you can see here, out of these 10 data, we have only 2 employees whose salary is less than 15. So these are the 2 employees. One is having 14, another is having 13. So you can just check the help and try to write your own script. So we have not written this script yet, so I'm going to write it. So it says like take a number from user and print its multiplication table. So take a number from user first. Okay, and then I have to print its multiplication table. So the if we look at the multiplication table, the number is multiplied first with 1, then 2, then 3, then 4, then 5 until 10. So I will create one variable. This variable is having value 1, and I will write a loop. This loop will run so we want to run the loop 10 times. And I change the value so that this loop stops when the value of I reaches 10. So what I will do here, I will simply keep on printing I multiplied with E. So what we are doing here is we have started a loop, and this loop is running from 1 to 10. So I is having value in the beginning 1, and then 2, and then 3, and then 4, and so on till 10. And for each execution, so this is the block, and in each execution we are printing I multiply with A. So whatever value the user is giving, that value will be multiplied with the I. So in the beginning the value of I is 1, so the user given value multiply with 1, and this print statement will print the result. Then I value become 2, it will be multiplied with a user input, and so on. So let's see the output. I will clear the console. I will click on the source. So now it's asking me a value, and I want to print a multiplication table of 5. Yay. You can again execute it. This time I can give a big number. So it has printed the multiplication table for 23,456. Okay, so we have covered so far if-else, loop, construct. And if you look at the heading for these in help, they are known as control flow. And why is that? So when we write a program or when we write a script, these scripts are executed in a sequential manner. For instance, this statement will be executed, then next, then next, then next, then next. But these special construct like if else, for, while, repeat, break, next, they have power to change this execution flow. So that's why they are named as control flow. Okay, so I assume in the first session we have covered a bit of this part, but I'm going to show you again how to create a vector. So in the script I used a C function, and then I will show you how to create it sequential, colon, and repetition function rep. So a vector is actually a collection of data of same type. So in the previous script I created a vector of employee salary. So that was the one way. Using C function, you just simply write your number or any value. So now I have created a vector of numbers. I can also create vector of character. Let's say so this time I have created a vector of character. So in vector it only store a single type of data. Now there is another function seq. You can generate a vector. So this function, in this function you have to specify start of the sequence. So let's say I want to start a sequence from 1, end of the sequence. So I want to generate a vector from 1 to 100. So if I only specify start and end, the sequence by default will take step size of 1. So it will generate a sequence like 1 2 3 4 5 6 7 8 and so on till 100. Now what I want to do, I want to have a different step size. I want to increase value by 0.5. So as you can see, 1 1.5 2 2.5. So you can specify your step size here. You can look for the help in the help. So here it will show you all the description and the example. Next we are having colon operator. So I have to generate a sequence from 1 to 100. So this operator takes step size 1. You cannot change that step size with here. So you specify start, you specify end, and it will generate a sequence with a step size 1. But in case of seq function, we can also change the step size. Now the fourth way is to use rep function. So sometimes we want to generate a vector with same value which are stored the same value with a particular number of times. So for instance, I want to have a vector with a value 5 50 times. So how I will do that? I will use rep. Here I will specify the value. So I want 5 to be repeated how many number of times? 50 times. Let's print a. So as you can see, a is having 5 repeated 50 times. So these are the 4 different way of creating vector. How to access vector, how to access element from vector, count, delete. So I am going to cover it quickly. So first of all, in order to count the data in a vector, you can use length function. Now let me take another vector. So if you look at this vector, we are having 5 element, and if you go to environment, our variable a is having these 5 element, and it also showing num, like this is a numeric vector, and then this is the index. So what do I mean by index? So if I ask you what data is stored at third location, at third position, so you will look at this data and then you will count first, second, and this is third. So this is the data stored at third position. So similarly, in a vector you can access any data element by specifying the index. There are concepts like index slicing, which I'm going to cover in next tutorials. Then how to delete a vector. So as you can see here, my vector A is having 5 elements of numeric. I want to delete it. I will simply assign null. My vector, all the data is deleted. Okay, now let's talk about descriptive statistics. So I'm not going to cover this entire this descriptive statistics in entirety. So when we talk about descriptive statistics, there are 3 main points. So the first point is distribution. By that I mean when you have a large amount of data, you want to see what kind of values are there in your data and how many number of times those value are repeating. Then we are having central tendency. That means when we have a data, we sometimes want to see what is the center data, what is the center data element in the data set. And the third is dispersion. So the dispersion is like how your values are spread, how your value are dispersed. So we will look at each of these points in a detail. So by distribution, I simply mean frequency distribution of individual values or range of values. By that, what I mean, so let's say I have a data test score of data of 10 students. So these are the test score out of 10. Now when I plot this data, so this plotting is showing you how many number of times a value is occurred in this data. So there are 2 times 3 value, 2 times 4, 3 times 5, there is no 6, and 1 times 7, 8 and 9. So this plot is showing the frequency of individual value. Okay, we simply counted frequency for each value. So for instance, how many number of times you can see 3 in this data? So 1 and 2, 4, 1 and 2, 5, 1, 2, 3, 6, there is no 6, 7, 1 time, 8, 1 time, 9, 1 time. So this frequency distribution of individual value, so this is the distribution. Now just consider another example. So we have a data like this one, and as you can see here, each data almost different to another data. And if we are going to follow the same approach like counting a frequency for individual value, we won't be having any good plotting for this data. So for such cases, we will go for another option which says range of value. So instead of counting frequency for individual value, we count frequency for range of value. And by range I mean so if we look at this graph, so here we can see there are around 15 elements which are in the range of 0 to 0.5. Okay, so now we have not counted individual value, we have counted the range. So for instance, how many elements, how many data elements are in this data set in the range 0 to 0.5. So they are around 15. So let's say there are 14 data item from 0 to 0.5 range. So we have plotted 14 here. So this is the another approach. So when we say distribution, so distribution is simply your frequency distribution of individual value or range of values. And this distribution actually helps us to understand the data, like what kind of values are there, how many numbers, what is the frequency of those values. Okay, now let's move to next point, central tendency. So central tendency, when we have a data distribution, we want to find out what's the center data. And there are multiple ways, and in statistics it can be computed by mean, mode, or median. And I'm going to show you what is the difference between each of them. So mean is simply the average. So if I'm using my same data, test score of 10 students out of 10, so for average I will simply compute the total of entire data and divide it by the number of data items. So in our data set there are 10 numbers, so I simply added them and divided by 10 and I got 5.3. So the mean of my data is 5.3. Then I'm coming to mode. So for mode we simply count the frequency of each values. So here we counted each data item frequency. So 3 2 times, 4 2 times, 5 3 times, 7 8 9 1 1 1 times. And the mode of data is most frequently occurring value. So from this table we can see 5 is the value which has occurred mostly. So therefore the mode of this data is 5. And then we are coming to the median. So median, middle value in the sorted list. And what does that mean? So we simply take our data, we sort our data, and then we take the middle value. So if there are two middle value, people sometimes use the average of those value, and some try to interpolate the value. And if there is only a single value, then that middle value will be taken. So in our example we have 10 data items, so we have in the middle two values, 5 5, and as these values are same, so we will take median 5. So mean, mode, median, they can be used to get the central data of your distribution. We are not going to talk about pros and cons for each of them. We are going to cover these once we start analyzing real data. And now the dispersion part. So the dispersion part will give you an idea about how your values are spread in the data. And one very simple measure is you get the maximum value from your data and minimum value of your data, and then you compute maximum minus minimum. So it will give you the range of data values. So it will give you the dispersion of your entire data set. Okay, like what's the range of data, what's the range of data values. Now the next measure which can be used for the same, and I think it is very important to understand, is standard deviation. And in order to explain it, I have discussed this concept in the next slide. So we are going to use a very simple example here, and let's say there is a person X, and this person wants to cross a river. So this person height is 175 centimeter, and he has access to river depth data. So this depth has been measured at various places, and this data look like something this one. And now as you can see here, at some places it's not that much deep, but in the middle it's like the depth is around 180 centimeter. So this person got this data and he knows some of the statistics. So what he did, he simply computed the mean, and the mean of the depth data was 170. And then he was like happy, oh, the mean of depth mean is 170 and my height is 175 centimeter. That means I will not drown if I cross the river. But do you think this is the case? So this is a simple case which shows how a mean of a data can give you a inaccurate picture about the data. So mean cannot always convey the accurate information about your data. So how we can have more information? So I have taken one more example here. So just consider three classes. There are 5 students in each class. This is just for illustration purpose. And these are the score of those students out of 100. So in class A, all students got same marks. In class B, some students got higher, some students got lower. And in class C, 3 students got 100 out of 100, but 2 students got very low marks. Now if we compute the mean for all three classes is same, 80. And if they are reporting these scores to some higher authority and saying the mean test performance in our class was 80, though it is true, but still if we look at the data, there are differences between the data, the way the value are different from each other or from mean. So in the class A, if we look at each value and the mean, so all values are similar to the mean, so there are no changes in these value from the mean. So that's why the standard deviation in this data is 0. Here some values are higher than mean, some values are lower than mean. Standard deviation is 10. And in the last case, C, the standard deviation is higher. So this standard deviation actually helps you to understand how the values in the data are deviated from mean, and it helps in understanding the dispersion of this value. That's why this is like is of a great importance to understand. So in this session we have simply we covered only simple concepts from descriptive statistics, and in the next session I will show you some of the distributions such as normal distribution, and we will see when we have such kind of distribution how we can answer questions like how many people, what percentage of people has the same score as us, and question like for what percentage of people our score is better. So I hope you understood some of the concept at least. So we will meet in next session. Thank you very much for watching.